Hey guys, Mr. T here, just doing a solutions video to Statistics Practice Test 2 for Year 11 General Maths. This is a Kanye test, even though it's number 2, I'm giving it to you first, because the next practice test is closer to the real thing. So, starting off, what kind of data? Classified data obtained from following situations: categorical, discrete numerical, or continuous numerical. So the number of phone calls a hotel receptionist receives per day. So there's going to be a number. I'm going to count that, not measure it. So it's going to be discrete numerical. It's a discrete numerical variable. What kind of data is it? When you ask people who's your favorite rapper, so that's not going to be a number, so that's going to be a categorical variable. Weighing the students in a class, well, you're weighing it, therefore you're measuring it, so that's a continuous numerical variable. Right, so that's the first page down. Moving on. The following is a bar chart. Shows the percentage of working people in town employed in private companies, work for the government, or are self-employed. This is just reading the graph. Is the data categorical or numerical? Well, the data that you're collecting is whether they're private, government, or self-employed. Those are words, so it's categorical. Approximately what percentage of the people are self-employed? So I need to look at the graph. I need to look at the self-employed column. So how do I draw a straight line in this? A straight line across from there. Now 7 or 8, I guess. So approximately 1%. What approximate percentage? Approximately 7 to 8% are self-employed. So that's just an example of reading off a graph kind of question. Moving on. Kanye West held an album listening party for his album and listened to his own album 30 times. Every time he listened, he recorded how long it took before he became emotional. So here's his results. Using appropriate class intervals. So, in the teaching you've been given, there should be 5 to 10 class intervals. You're going to decide the class intervals based on the data. The lowest bit of data we've got 0. And just scanning through, it looks like the highest bit of data looks like 34. So what kind of divisions of class intervals can I do that's going to give me 5 to 10 class intervals? It's not going to be 0 to 10, 10 to 20, 20 to 30, because that's only going to be 3. So we're going to have to go to the next best thing, 0 to 5, 5 to 10, etc. So, daily frequency table, this column is going to be the time, and we're going to go 0 to less than 5, 5 to less than 10, 10 to less than 15, 15 to less than 20, 20 to less than 25, 25 to less than 30, and 30 to less than 35. We only need to go that far because the data only goes up to 34, it looks like. Need another column here. That's going to be the tally column. Another column for the frequency, because you've been asked to do a tally frequency table. So tally, that is not how you write tally. Tally and frequency, F-R-E-Q. So 0 to 5. Like if you're on your tests, you get to cross things out. So 0, 0, 9 is 5 to less than 10. 10 is going to go in the 10 one. 23, 25, 0, 0, 34, 32, 0 and 0 again, 30, sorry for the sniffles, I'm still ill, 0, 4, 5, 0, 17, 14, 3, 6, 0, 33, 23, 0, 32, 13, 21, 22, 6. Oh, cross that off, make sure I don't miss anything. So it looks like I've got frequency of 12, 4, 3, 1, 4, 1, and 5. So there's your tally frequency table for that particular data. Moving on, using the tally frequency table from part A, construct a histogram for this data. So a histogram looks like a column graph, but it has no gaps. You will lose marks if you show gaps in a histogram. So you must be careful with that. Got an x-axis. I'm going to draw a y-axis. Nope, I wanted a straight line. This app is not the best, but it'll do. Drawing now. So, no gaps. So this is going to be 0 to less than 5, 5 to less than 10, 10 to less than 15, 15 to less than 20, 20 to less than 25, 25 to less than 30, 30 to less than 35. Those are going to be the bars. What does the x-axis represent? It represents the listening time. Unfortunately, I didn't give units for the listening time. So just write listening time. You normally put units. This is Kanye West, so I'd say seconds. This axis would be frequency. No, not frequency. Frequency. So it's going to be, what was the highest frequency we had? We had 12, so I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, so it's fine. If I scroll up, 0 to 5 is 12. 0 to 5 was 12. I think 5 to 10 was 4. 10 to 15 was 3. 15 to 20 was 1. 20 to 25 was 4. 25 to 30 was 1. And 30 to 35 was 5. Let's just double check. 12, 4, 3, 1, 4, 1, 5. Done. So I can make these proper bars now with no gaps using this terrible line function. It's not connecting. It'll do. Oh, that one connected. Last one. Done. Constructed a histogram for this data. Comment on the shape of this distribution of Kanye's listening times. Well, what kind of shape do we have? You have a shape that looks like this. It's mostly up here and then it scrolls down. So, more data on the low end, therefore positively skewed distribution. Okay, so that moves on to the next question. He teaches rapping in his spare time. His students had a test. Kanye recorded the time taken in minutes by each student to complete the test. Make a dot plot for this data. So a dot plot is the it almost looks like a column graph, but instead of columns it's made up of dots. One dot for each occurrence, so there's no frequency y-axis. So time in minutes, how do I know what the axis goes from? I need to find the minimum, which is 22. I need to find the maximum, which is 72. So really I need to go from 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, just extend it to 80, 74, 76, 78, 80. That's my scale. I've only got up and down because I don't have much space. Okay, so 56, where's that dot going to go? Here. 57, here. 47, between 46 and 48. 68. 52. 51. 43. 22. 59. 51. So there's already been a 51, so I need to draw this next 51 above it with even spacing. 39, between 38 and 40. 54. 52. 69. 72. 65. 45. 44. 55. 56. 49. And 50. So there's your dot plot for the data. Make a stem plot for this data. Make a stem plot for this data. So a stem plot has two sections. A stem, I'll indicate that, a stem, and a leaf section divided by a line. The leaf section is made up of all of the last digits of the data. The stem is made up of all the first digits of the data. Now we know what the minimum bit of data is, it was 22. The maximum bit of data was 72. So the stemp's going to need to go from 2, 5, 6. It needs to go from 2 to 7. So now we can do the leaves. It's going to be easier for me to do this in order because I just made a dot plot of this data and I can see the order. The lowest dot was 22. The next dot was 39. The next dot after that was 43, 44, 45, 47, and 49. After 49 it was 50. There was two 51s. There was two 52s. There was no 53, there was a 54. There was a 55. There was two 56s. There was a 57. And there was a 59. No 60. There was a 65. 68. A 69. No 70. There was a 72. So that's the data in the stem plot. It's in order. It was easy to do it in order because there was a dot plot already there, just above it. You'll lose a mark if you do not include a scale. So a scale, choose any of the data points and explain what it reads. So 2/2, that's going to represent 22 minutes. Okay? Comment on the shape of the distribution of the test completion times. This is a stem plot. So from the top is the low end, the bottom is high, and the sort of shape that we had was sort of goes up and then there's a spike and then it goes down. So there's more data on the high end, so more data on the high end, therefore negatively skewed. You could say slightly as well, but negatively skewed is fine. You're indicating there's more data on the high end. Use the stem plot to find the median, quartile 1 and quartile 3. So median. The median formula tells you the position of the median. And the position is n plus 1 over 2 th position. How many bits of data were there? I believe there were 14 students. How many students were there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And there's 22 students. 22 plus 1 over 2. 23 over 2. That's going to be 11.5th bit of data in order is the median. So between 11 and 12. So I'm going to use the ordered stem plot to count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the median is between 52 and 52. The average of 52 and 52 is 52. Quartile 1. So quartile 1 is the median of the bottom half of the data. Okay? There was 22 bits of data. So the bottom half of the data is going to be 11 bits of data. So 11 plus 1 divided by 2 is going to be 12 over 2 is going to be 6th piece of data in the bottom half. And scroll up to count. 1, 2, 3, 4, 5, 6th piece of data there, which is 47. 47. So Q3, there's going to be 11 bits of data in the top half, it's going to be 12 on 2 again. Going to be 6th. So the 6th bit of data in the top half. 1, 2, 3, 4, 5, 6. So that's 57. Okay? So that's us using the stem plot to find median, quartile 1, and quartile 3. Moving on, Kanye West has 14 personal assistants. Their weekly pay in dollars is given below without using graphics calculator function. So what I mean by that is not getting it to work out. Not using stat calc. You can still add, divide, etc. Okay? Because it would take forever to add all these up. So find the mean weekly pay, total pay, add them all up on the graphics calculator, and you're going to get 3970. Number of assistants, so mean is 3970 divided by 14 assistants. In your graphics calculator, that comes to $283.57 to 2 decimal points. Weekly pay. Find the median weekly pay. Median is equal to n plus 1 over 2. If there was 14 bits of data plus 1 over 2, 15 over 2, 7.5. That's the wonkiest 5 I've ever drawn. 7.5 bit of data. The only problem is the data isn't in order right now, so I need to put it in order. So the median is the 7.5 bit of data in an ordered data set. So the lowest bit of data that I've got here is 185. The next is 190. The next is 210. There's two 210s. The next is 215. The next is 245. The next is 265. The next is 270. The next is 280. The next is 285. The next is 300. The next is 315. 320. And the last is 680. Now we can find the 7.5, which is the average of the 7th and the 8th. So 1, 2, 3, 4, 5, 6, 7, and 8. Those are the two middle ones. The median is going to be between those. So 265 plus 270 divided by 2 is going to be 267.50 median weekly pay. Yep. Find the median weekly pay. Find the 5-number summary. So the 5-number summary is min, Q1, median, Q3, max. I can see them in there. It's 185. The median I just worked out. The max I can see just above is 680. Q1. So do some working out on the right hand side. Q1 is the median of the bottom half of the data. The bottom half of the data has 1, 2, 3, 4, 6, 7 bits of data. 7 plus 1 over 2 is equal to 8 over 2 is equal to 4th bit of data. 1, 2, 3, 4. So Q1 is 210. Why is that pink? That was a highlighter. 210. the top half of the data is also 7 bits of data. 7 plus 1 is 8, divided by 2 is 4, so 1, 2, 3. Fourth bit of data is 300. So Q3 is 300. That's the 5-number summary of the data. Find the range of the weekly pay. Range equals max, take min, is equal to 680 minus 185, is equal to $495 range. Find the interquartile range. IQR, standing for interquartile range, is Q3 minus Q1, which was 300, minus 210, which was $90. So that's the interquartile range done. Moving on, find the standard deviation in the weekly pay. Okay, so these are going to be the toughest question types in your test coming up, because standard deviation is a long calculation. You're doing it manually, and there's many places that you can stuff it up. Okay, so the first thing to keep in mind is you need the mean. The mean of this data was 283.57. Why is that important? Because the standard deviation, you need to work out all the deviations, and the deviations are the data values minus the mean. So it's suggested that you do a table of the data, stop there, the deviations, let's make that bigger, and the deviations squared. Give that some space too. So that's the headings of my table set up. I'm going to draw lines for that. Set up my table. Horizontal line 2. And finish off underlining these. Okay. So the data, which was on the previous page, you had there was 185, 190, 2 210s, a 215, a 245, a 265, a 270, a 280, a 285, a 300, a 315, a 320, and then there was that bigger one which was 680. So I can put a line under here too. Alright, so the deviations. You're going to go the piece of data, 185, minus the mean, which is 283.57. And that was negative 98.57. Okay? So you continue that, 190 minus 283.57. That came to negative 93.57. So this is where you can easily stuff up, so you need to be careful. 283.57, that comes to negative 73.57. 210 minus 283.57, now that's the same. 215 minus 283.57, negative 68.57. 245 minus 283.57 was negative 38.57. 265 minus 283.57. That was, on the calculator, negative 18.57. 270 minus 283.57 comes to negative 13.57. 280 minus 283.57, negative 3.57. 285 minus 283.57. That's a bigger number now, so it's not going to be negative anymore. It's going to be 1.43. 300 minus 283.57. 16.43. 315 minus 283.57. 31.43. 320 minus 283.57. Calculator, 36.43. And 680 minus 283.57. Oh, that's a big number. It comes to 396.43. Okay, so the next step is the deviation squared. So you have to put the deviation in brackets so that your calculator doesn't get confused and deal with the negative number incorrectly. You must bracket it and then square it. So that comes to 9716.04. Rounding to 2 decimal points, be consistent. That is negative 93.57 squared. That comes to 8755.343. Trying to make my writing a bit better so I don't confuse myself later when I'm adding it all together. Negative 73.57 all squared. 5412.54. Lucky for us, that's the same number, so I don't need to put in the calculator again. 5412.54. Negative 68.57 squared. 4701.84. Negative 38.57 squared is 1487.64. Negative 18.57 all squared. 344.84. Negative 13.57 all squared. 184.14. Negative 3.57 squared. 12.74. 1.43 squared. 2.04. 16.43 squared. 269.94. 31.43 squared. 987.84. 36.43 squared. 1327.14. And this is going to be a big number, 396.43 times by itself. This is going to be 157156.74. Okay, not done yet. Why aren't we done yet? Because the standard deviation formula looks like this. ST dev is equal to the square root of the sum of all the deviations squared over the number of data minus 1. I need the sum of all the data. So, sum of all squared deviations. the squared deviations are these things. So I need to add them all together. So I'm going to put in the calculator, add them all together, and it's going to be a big giant number. If you make any mistakes, you're going to get it wrong. So be careful, take your time. 9716.04, 8755.34, 5412.54 twice, plus 4701.84, plus 1487.64, plus 344.84, plus 184.14, plus 12.74, plus 2.04, plus 269.94, plus 987.84, plus 1327.14, plus 157,156.74 equals 195,771.36. That gives us the total 195,771.36 on the top line. How many bits of data were there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 14 bits of data. 14 minus 1. That comes to 195,771.36 divided by 13. Still the square root. I'm not doing the square root yet. That comes to 15,059.34 to 2 decimal places, and the square root of that is 122.72 to 2 decimal points. That's the standard deviation of all that data. Okay, moving on. The following data gives the number of fan mail letters Kanye West received on each of the last 36 days. Find the 5-number summary of this data. Now, it doesn't say anything about not using any graphics calculator stuff. So, how do you do it? Stat 1 edit, enter all data. It's your first step. Second step, stat, press the right arrow, select calc, 1 var stats, and there you've got it. So the 5-number summary, if you scroll down, min, Q1, median, Q3, max. So the minimum bit of data, according to 1 var stats in the calculator, is 0. Q1, 7.5, median 14.5, Q3, 21, max 44. Check the data for outliers by calculating the upper and lower outlier boundaries. So upper boundary is equal to Q3 plus IQR times 1.5. So that means I need to know the IQR. The IQR is Q3 minus Q1, which is 21 minus 7.5, which is 13.5. So it's going to be upper boundary 21 plus 13.5 times 1.5. That comes to 41.25. That's the upper outlier boundary. You've got a bit of data that was the max of 44, therefore upper outlier of 44. Lower boundary. Is Q1 minus IQR times by 1.5. Q1 was 7.5 minus IQR was 13.5 times by 1.5. That comes to negative 12.75. We don't have any data passed to the left of 0. We don't have any negative data, therefore no lower outliers. Construct a box plot of this data with outliers indicated if there are any. So a box plot, you need a scale. I'm going to do a straight. Missed it. There we go. The lowest bit of data was 0. 0. I need to get up to 44, so 50 at least. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. I can stop there. You'll lose marks if you don't indicate this. The scale, so the scale represents the number of letters received per day. Alright, so if there are any. We found that 44 was an outlier, so I'm going to put a star there. Once you've worked out that 44 was an outlier, is an outlier, the next best number, the next biggest number, so 30 is the biggest I've seen so far. 31 appears to be the next biggest number, so that's going to be the max, the end of the whisker for this particular box plot. So 31. Q3 was 21, so that's here. Median was 14.5. 15 would be here, so 14.5 would be halfway between 14 and 15. 7.5 is Q1. So 7 would be here. 7.5 would be halfway between 7 and 8. So here. And the min was 0, and that wasn't an outlier. So there we go. Just finish the rectangle and finish the whisker. So outliers indicated if there are any. Correct. Done. On what percentage of days were more than 20 fan mail letters received? More than 20 means 21 and above. And what do we notice here? The box plot, Q3 is at 21. So this represents 25% of the data. Therefore, 25% of days there were more than 20 fan mail letters received. Right. Is that all the pages? Alright, that's it. So that is the Kanye test, practice test 2 for Year 11 General Math Statistics. Hopefully that helps you out, and I see you in the next video.